Okay, so this will start the new notebook on chapter 7, and it's going to deal a lot with logarithms. And we've worked with logarithms before. We did a little bit with the natural logarithms. We did more with common logarithms, the LOG. But now in this chapter, we're also going to look at taking the derivatives and the integrals. Okay, so this will start a new notebook. Okay. And this one, just call it the natural logarithm function. Okay, first, what is a logarithm? It's just an exponent. Yep, if you forget everything else, remember that one statement. Okay, a logarithm is just an exponent. Okay. Remember in Algebra 2 you went from exponential form to radical form, logarithmic form, back and forth. Okay, let's look at a couple of those. Some of this is just to refresh your memory. Okay, let's look at logarithmic form and exponential form. But you should be able to go to radical form also. Okay, so if I have something like this, if I have like 10 squared is 100, that's exponential form. If you go to logarithmic form, it's the log of the number, the log of 100. The base, remember this is considered the base, and the base is the little subscript, so base 10. And if it is base 10, it's a common logarithm, and you don't have to write the 10 down. And the exponent is just the logarithm. Okay, so those should kind of pair up. Okay, we're going to go color coded here. Okay, so the exponential form and the logarithmic form. Okay, if you did that on the calculator, remember there is an LOG, there is an LN. On the calculator, if you just did the log of 100, you don't have to type in the base, and it should give you the log of 100 is 2. What it's really telling you is 10 to that exponent. And if you look right above the LOG, there is a second function. So if you do that, it should take you right back. Okay. If the base is not base 10, okay, like if I said the log of 81 base 3 equals what number? Okay, I cannot just type that in on the calculator because it's not base 10. I could go to exponential form and say 3 to what power equals 81. If you work it that way, you want to get the same base. 3 to the x power, and 81 is like 9 squared, or 3 to the 4th power. If the bases are the same, then you set the exponents equal, so x equals 4. Or on the calculator, remember we used what they call the change of base formula. Whoops, spell it wrong. Right? Change of base formula. And that is the log of the number. It's the log of the number divided by the log of the base. You really use these a lot in different science classes too. So the log of the number would be the log of 81. And the calculator is going to put that left parentheses. You need to close it with the right parentheses. Divided by the log of the base. Divided by the log of 3. Okay, so if you test that on your calculator, you're going to put the log of 81, close the parentheses, divided by the log of 3, close the parentheses, and you get 4. Okay. So you can either do it by hand, and when we did it by hand, we had to make sure we got the bases the same. Once you get the bases the same, then you can set the exponents equal. Okay. Let's look at another example. Say they gave you the log of 1 over 625 base 5 equals x. Now, if I did not have a calculator, okay, I would go to the same base. So I'd say 5 to the x power equals 1 over 625. Now I'm trying to get the same base, so go to base 5. And 625 is 5 to what power? 4th, right? 5 to the 4th. Okay, and then remember when you move that up, the base stays the same. When I move that up, it changes that to a negative exponent. So when the bases are equal, then set the exponents are equal. So you should get negative 4. Now, if I do it using the change of base formula, I'm going to do the log of 1 over 625 divided by the log of the base, divided by the log of 5. Okay, so take the log of 1 divided by 625, divided by the log of 5, and you should get negative 4. Okay? So you ought to be able to do these both algebraically and check them on the calculator using the change of base formula. Any questions on that part? Look familiar? Okay? Okay. Then we also started talking about, in pre-calc, we started talking about natural logarithms. Okay, natural logarithms have as a base, they have a base e. And e is called the natural exponential function. Do you remember what E equals? Look on your calculator, right above the ln. You got the e to the x, so do e to the first power. Okay? And they're going to, most of the time they will round it. It is approximately 2.718 when you do e to the first power, and that's above the ln. Okay. This decimal is similar to pi. Okay, it is irrational. It is non-terminating. Means it doesn't have an end. And it is non-repeating. But very similar to pi, where we say pi is 3.14, we've rounded it. Okay, same idea. E, they're going to round it to like approximately 2.718. Okay. Okay, so what we did up above, we're going to look at natural logs. Okay, so in the logarithmic form and the exponential form. So if they gave you, figured the natural log of 3, okay? So on your calculator, you're just going to do natural log of 3. And most of these are going to round it to 4 decimal places, 1.0986. And what that really means is it's understood that there is a base E. Anytime they use ln, it's understood to be base E. So really it's E to the, and I've rounded it for the paper, and that should equal 3. So if you go back above the ln and do second function e to the what power, and then do second function answer, and it should bring you back to 3. Okay? And you can change this to floating, or I've got it on 4 decimal places. Okay? So if I did like the natural log of 2, natural log of 2, and I've got 0.6931, so that's like e to the 0.6931 equals 2. Okay. Now, I know we've done these before. This is probably the 3rd time we've done these, but you need to go back and review these. the laws of exponents and the laws of logarithms parallel each other, and we're going to use them in a little bit to solve a problem. So separate your paper into two columns. Let's do laws of exponents and laws of logarithms. They parallel each other. There are three laws. Okay. First one, if I take x to the a power times x to the m power, when you multiply monomials and the bases are the same, what do you do with the exponents? You add them. So x to the a plus m power. Okay, that parallels the laws of logarithms. Take the we're going to do this with natural logs this time. Sorry. Natural log of a times x. If you multiply the numbers, what do you do with the logarithms? Add them. So it'd be the natural log of a plus the natural log of x. Okay? And you can fill in numbers. You know, like you could say the natural log of 5 times 3. So if you did the natural log of 15, let's do it on the calculator. If you did the natural log of 15, it ought to be the same as if you do the natural log of 5 plus the natural log of 3. Okay, so if I did a natural log of 5, close the parentheses, plus natural log of 3, I ought to get the same answer that I got on natural log of 15. Okay. Second law, if you divide monomials, x to the a power divided by x to the m power, if you divide monomials and the bases are the same, subtract them, be x to the a minus m, and that parallels the second law of logarithms, the natural log of a divided by x. If you divide the numbers, you subtract the logarithms, so it's the natural log of a minus the natural log of x. Okay, and you can fill numbers in on those two. Okay. Okay, look at the third law. X to the a power, and then when you raise that to the m power. When you raise a power to a power, you multiply them, right? So you'd have x to the am, and then on this one, you'd have the natural log of, on this one I'm going to write it x to the, I'm going to use a different letter here, x to the n power, okay? And it's move that out front. So you multiply it, just like we did on the other part. So it's n times the natural log of x. Okay. Okay. While we're on that one, I am going to do one. If I said figure the natural log of 1 over x, and that's like to the first. Okay. That's the same as the natural log of x to the negative 1 power, right? Move that out front, so you'd have negative 1 times the natural log of x. Or they might just write it as negative natural log of x. Okay? And that's just using the third law of logarithms. Okay? Okay, now we're going to go through. Some of this is a little mixed. Draw a little separator there. We're going to look at some. First, I want you to look at a graph. In y sub 1, graph the natural log of x. Okay, and let's do it in just zoom standard. So in y sub 1, clear anything out you've got in there and do the natural log of x. Okay, and let's go zoom standard, zoom 6. Okay, so you should have a sketch. It's going to look something like this. Okay. Okay. Now in y sub 2, I want you to take the derivative of that. Okay, so in y sub 2, I I want you to do the numerical derivative. It's been a while since we've done this one. And y sub 1 comma x comma x. Okay, so go to y sub 2, math 8 for the numerical derivative, and then the vars key, right arrow over to y variables function, pick up y sub 1 comma x comma x. Okay, and turn that first one off so you can see what the derivative graph looks like. What's the derivative graph for the natural log of x? Okay. And you should end up with a graph that looks, you may want to change the window and zoom in a little bit, but you should end up with something like that. And that is the derivative graph. Okay. Okay, now in y sub 3, go down to y sub 3, and I want you to put in 1 divided by x. Okay, 1 over x. Turn off y sub 2 for a minute, and just graph the 1 over x. Okay. The 1 over x is going to give you both parts of a hyperbola. Okay, but if you looked at the 1 over x, if you just do the 1 divided by x, it would just, if you looked at the positive part of that, you're going to get the same graph. Okay? Okay? So the derivative of the natural log of x is 1 over x. So the derivative of the natural log of x with respect to x is 1 over x. Now, when I first started teaching calc, that's all they had in the book. And then when I started working the problems, I was missing the answer. And I'm going, what is wrong? I'm falling there. Come to find out, they did not. It's 1 over x, and then it's times the derivative of that. What's the derivative of x? Yeah, they left that critical part out. Okay, if they had shown me that one thing, I would have got all my other answers right. Say that again. So how do you want me to write it? So for right now, you'll understand why in a minute why I'm writing it like that. But if you don't have that, if you don't see that one, you're going to miss the next part. Okay. So here's the problem. I saw this in the book without that 1, okay? And then the problem was this. Take the derivative of the natural log of 5x with respect to x. And I did this. I said it's 1 over 5x and got the wrong answer. Because it's times the derivative of what's inside. So it's times the derivative of 5x, which is 5. Okay? And then that's like 5 over 1. So final answer, 1 over x. If they had shown me that 1, okay, so that leads to what Dustin's saying. Derivative of natural log of u. You may want to use a different grouping symbol. Okay? And that equals 1 over u, then times the derivative of u with respect to x. And I'm guessing you like that one better. Yes. Okay? Because the first one was just a specific example, and this one's in general. Okay? Okay, so if they give you if they give you the example, say they ask you to figure the derivative of the natural log of x squared plus 3, the derivative of the natural log of x squared plus 3 with respect to x. My u is the x squared plus 3, so it's 1 over x squared plus 3, and then you have to say what's the derivative of this. So it's times 2x, and that's it, right? So final answer is 2x over the x squared plus 3. Okay? Okay, guys, I would add this to your card, the change of base formula. It's the log of the number divided by the log of the base. Okay, then I want you to add this formula. The derivative of the natural log of u is 1 over u times the derivative of u with respect to x. Add that to your card. Okay, now draw another little separator there. Okay, I want you to graph in y sub 1. I want you to graph e to the x power. So clear out in y sub 1 graph e, so you have to do it's right above the natural log e and then to the x power. And zoom 6, and we could do zoom square to square that up a little bit. Okay, but you should end up with something that looks like this. Okay, label that. That's your y equals e to the x. Okay, and then y sub 2, I want you to graph the natural log of x. So do the natural log of x. And graph that. Okay, and that should end up to be something like this. Okay, and this is just kind of a rough sketch. Label that y equals the natural log of x. Now, if you remember earlier in the year we did inverses. Inverses are symmetric about the line y equals x. So if I graphed in y sub 3, if I graphed y equals x, and if I do a zoom 5, zoom square, it's going to square it up a little bit, make it look better. So these two are inverses. Okay, label them that way. The exponential and the logarithmic, they are inverses of each other. For them to be inverses, they've got to be symmetrical about the line y equals x. You ought to be able to fold this one, fold it over that line, and this y equals x ought to lie right on top of that one. Okay? Okay, now I want to go through an example of what they call logarithmic differentiation. Logarithmic differentiation. Say they ask you to find the derivative of y with respect to x if y equals, up in the numerator, the quantity x squared plus 1 times the quantity x plus 3, that's to the 1/2 power. It's all over x minus 1, and because of the denominator, x cannot equal 1. Now, we're trying to find the derivative of that. Okay? To find the derivative of that, the very first step, if this is in exponential form, you use logarithmic form. First step is just take the log of both sides, and we're going to use ln. So natural log of y equals the natural log, and you just repeat that whole thing. So it's x squared plus 1, x plus 3 to the 1/2 power, that quantity, over x minus 1. Okay, and make a note outside. First step, take the ln of both sides. That just gets the problem started. Okay. Now you apply the laws of logarithms. If I am multiplying these two quantities, what do I do with their logarithms? Add them. So I need the natural log of x squared plus 1 plus the natural log of x plus 3 to the 1/2 power. If I'm dividing by the x minus 1, I have to subtract the logarithm. So subtract the natural log of x minus 1. So if you're multiplying these two quantities, you got to add their logarithms. If you're dividing by this quantity, you got to subtract the logarithm. Okay? One more step. Third law of logarithms. This exponent's going to go out front. Okay? So on this line, it's the natural log. Just repeat this part. I'm doing it one step at a time. So it's 1/2 the natural log of x plus 3 minus the natural log of x minus 1. So that's, we applied all three laws so far. Okay. Now you take the derivative of both sides. So on this, you may want to write a note here. Apply the three laws of logarithms. You can abbreviate it. Okay. Now you take the derivative of both sides. Derivative of a y term. We've got to use implicit differentiation. Derivative of natural log of x was 1 over x. So derivative of natural log of y is going to be 1 over y, but it's a y term, so it's got to have that extra dy over dx in it, just like we did on implicit. Okay. Now, what's the derivative of the natural log of x squared plus 1? What did we just do back on that other page? 1 over that, right? 1 over x squared plus 1. Then times, what's the derivative of x squared? 2x. Derivative of 1 is just 0. Plus, leave the 1/2. What's the derivative of natural log of x plus 3? 1 over x plus 3 times 1. Minus, derivative of natural log of x minus 1 is just 1 over x minus 1, and then there'd be a times 1 in there also. Okay? So make a note on this step. It was take the derivative of both sides using implicit differentiation on the left side. Okay, implicit differentiation on the left side. Okay. Okay, now I'm trying to solve for dy over dx, so I've got to get rid of that. Multiply by y on both sides. So derivative of y with respect to x, and we can simplify. So I'm just going to have a y in front on this side. Now I can simplify this. This 2x can go up here on top. So 2x over x squared plus 1 plus, it's just going to be 1 over, I can leave it in factored form, or I can multiply out that 2 if I want to say it's 2x plus 6, or 2 times the quantity x plus 3, but 1 on top, minus 1 over x minus 1. So on this one I just multiply by y on both sides. But what does y equal? What did y equal? Yeah. You got to sub all this in for y. Oh boy. Okay, so derivative of y with respect to x. We got to sub in for that. So up in the numerator, we got x squared plus 1 times x plus 3 to the 1/2 power all over x minus 1. That quantity times all the rest of this. 2x over x squared plus 1 plus 1 over 2x plus 6. 1 over x minus 1. That whole thing is your answer. Do you have to simplify it more than that? Nope. That's it. Okay, that is your derivative. I have found the derivative. What is the derivative? It's awful. What is the derivative? What is first derivative? Got to go all the way back to August. First derivative is the slope of the tangent line at a specific point. So when you work yourself all the way down and you get this and you're going, what have I found? For whatever x value they give you, you have found the slope of the tangent line, okay, at that x value. Okay? That's your first example on logarithmic differentiation. Okay? Okay. Draw another separator. We've done a little bit with integration. Now we're looking at, or with differentiation, now we're going to look at integration. Okay, the integral of 1 over u with respect to u is defined to be the natural log of u plus c, some constant, because I didn't give you an a and a b value. It's an indefinite integral, and there's a little catch on this one, u is greater than 0. There's another formula, the integral of 1 over u with respect to u is the natural log of the absolute value of u plus c. And that's if u is a positive or negative differentiable function. Okay, so if you see an absolute value symbol around it, okay, you need to add this formula to your card. Okay. Now let's look at a couple of examples. This is going to look like integration with substitution. If I give you the indefinite integral, up in the numerator 2x, in the denominator x squared plus 3 with respect to x. Okay. Let u equal which one? Yeah, the x squared plus 3, right? And if you take the derivative of both sides, du is going to equal 2x with respect to x. Okay, now I should be able to sub in, okay, I can sub in u for that bottom part, okay, that's the u, and I can sub in the 2 dx, I can sub in du. Okay, so I'm going to have 1 over u with respect to u. But 1 over u with respect to u, the integral of that is the natural log. If you look up here at the formulas, okay, it's the natural log. So it's the natural log of u plus c. But what was u? X squared plus 3. So it's the natural log of x squared plus 3. And then plus c. And I'm not that worried, to be honest, I'm not that worried about the absolute value symbols. Okay, if it's a positive or negative differentiable function, if we could find the derivative, yeah, you'd have absolute value symbols around it. I'm not going to be picky on that part. Look at another one. They give you the integral. Up in the numerator is 1 plus cosine of x. Down in the denominator is x plus sine of x. And it's all with respect to x. Your clue is in the denominator, right? So on this one, let u equal the x plus sine x. Take the derivative of both sides. Derivative of x is just 1. Derivative of sine is cosine. And then with respect to x. Okay, so we're going to end up with 1 over u with respect to u. It's the natural log of u, and this one is going to have an absolute value, plus c. So it's going to be the natural log, and our u is x plus sine x. It's absolute value, sorry, it's absolute value. Okay, and then plus c. You need that plus c because it's still indefinite. Okay? Okay, and the last formula to add to your card, the integral, indefinite integral of e to the u power with respect to u is e to the u power plus c. Okay, so add this formula to your card. Okay. Now I assigned odds, so you should be able to work in, like on that. Like on number 1, the natural log of 4 divided by 9. They give you the natural log, write everything in terms of natural log of 2 and natural log of 3 using the laws of logarithms, basically. When you divide numbers, what do you do with the logarithms? Subtract them. So you do the natural log of 4 minus the natural log of 9. They want you to get it down to natural log of 2 and natural log of 3. Well, 4 is the same as, you can go 2 times 2, or you can go 2 squared. Natural log of 9, I can write that as 3 squared. Laws of logarithms, third law of logarithms says this exponent goes out front. So it'd be 2 times the natural log of 2. This one would go out front. 2 times the natural log of 3. You can write it like that. I think the author factors out a 2, but you don't have to. That's good enough. Okay? So don't make these hard. Okay?